A car is traveling down the road. The engine is applying a constant 500 newtons of forward force, and air resistance is applying 100 newtons of backwards force. The car has a mass of 200 kilograms. Part A, draw the free body diagram. Okay, so we've been practicing this. Let's go ahead and draw it again. X direction, are the forces balanced or unbalanced? Unbalanced forces. Y direction, balanced or unbalanced? Balanced. So all the forces in the y direction are balanced. So we have some normal force. The road is a solid surface. It's providing a support force. The car is not falling through the road. So it is balancing out the weight of the car, or the force of gravity. And then we have two forces in the x direction. It says the engine is applying a constant 500 newtons of forward force. So I'm going to assume it's moving to the right. That's my forward direction. And so we have this engine force of the engine, and I can actually put that number in because I know it. 500 newtons is given to me. And it says air resistance is applying 100 newtons of backwards force. So here's the air resistance force. We call it 100 newtons because that's what they've told us it is. Okay. Now I'm not quite done. I do want to write my two equations. So all the forces in the x direction, the net force in the x, is equal to, well, the force in one direction minus the force in the other direction. The engine force minus the air resistance force. And that's equal to the mass times the acceleration in the x. And then I can do the same thing with the y direction. Net force in the y direction is equal to all the forces up minus all the forces down. The normal force minus the weight, the force of gravity. And that's equal to the mass times the acceleration in the y. Yep. And the y direction acceleration is 0. These are balanced forces, x direction unbalanced.
So if you're in for B, why do you answer like
One more thing, and then we're going to answer that question. At this point, I also want to include any other givens that they've provided me. Is there anything else I need to add? Mass. So it's not part of my free body diagram, but really these are part of my givens. So I'm going to also state that the mass is 200 kilograms. Okay. Now, part B. It says, are the forces balanced or unbalanced? So what do we know from my free body diagram about the y direction? Yeah. So the acceleration in the y is 0, balanced y forces. The acceleration in the x is not equal to 0, so they are unbalanced x forces. And that's part B. Part C. What is the net force acting on the car in the x direction? So we're looking for the net force in the x direction. If we take a moment and look at our equation sheet. Here we go, forces. Let me just show you how I've written this on the equation sheet. So the net force in the x, there's my net force in the x. I wrote it just a little bit differently on our equation sheet. Can everyone see that there are two ways to find net force in the x? You can take all the forces in one direction minus all the forces in the other direction. That's one way to find net force. Or, just depending on what you're given, you can have mass times the acceleration in the x, and that is net force. For this question, which path do we want to take to find net force? We want to add and subtract the forces or multiply mass and acceleration? Yeah. Add and subtract the forces. Very good. So that's what we're going to do. Have I already written that equation on this page? Yeah. Isn't that this piece right here? Okay. So then net force in the x would be the forces forward, in this case it's the engine force, minus the forces backwards, the air resistance force. That's my equation. Now I put my numbers in. 500 newtons minus 100 newtons. So it's 400 newtons. I am well aware that you can all figure out 400 newtons, probably just from looking at that diagram, but I want the reason for it. You have to prove it. And your equation here is your proof. It's your reasoning behind why you can just take 500 minus 100. Questions about part C? Part D, calculate the car's acceleration. So at this point in the year, we have two different paths we can take to calculate acceleration. One is from the beginning of the year, motion equations. The second one now is the new stuff, and it's from net force. I can calculate acceleration. Looking at what they've given me in this problem, which path do I want to take to find acceleration? Yeah. Did they give me any motion equation givens? They gave me nothing. They didn't give me V original, V final, distance, time, nothing. So I have to use net force. So now I'm using this part of my equation that I've already written. I'm going to solve for acceleration. Acceleration is equal to the net force in the x divided by mass. In part C, we calculated the net force to be 400 newtons, divided by the mass that was given to us, 200 kilograms. And the numbers are really nice. 400 divided by 200 is 2 meters per second squared. Questions about part D? Okay, last part. Part E. If the car starts from rest, what does from rest mean? Yeah, what is 0? The original is 0 meters per second. How far will it travel? What's my unknown? Distance. In the first 10 seconds. Time. So time is 10 seconds. How many motion givens do I need to use one of my motion equations? I need 3. Oh, I also have acceleration. So that's my third given. There's no V final in this question, so I'm going to use the equation without V final. D equals V original multiplied by time plus the acceleration multiplied by time squared divided by 2. Where did I get that from? From your equation sheet under motion equations, so don't forget that you have that piece. Do I need to solve this equation, or is it already solved for me? It's already solved, so now I'm at the substitute my numbers stage. V original is 0, so 0 times anything is 0, so V original times t is 0, plus the acceleration, 2 meters per second squared, multiplied by time squared, 10 seconds squared, divided by 2. 2 divided by 2 is 1. 1 times 10 squared, 100 meters.